Hello viewers, this is Mithul here. In this module, we will be covering about module 4.2, which is types of constraints. Okay. Now, types of constraints. How many types of constraints are there? There are three kinds of constraints. One of them is entity. The second one is the referential, and the third kind of that constraint is the domain, in which like primary key, unique key, foreign key, not null constraint, default constraint, and check constraints are there, right? So let's just see them in action. Okay, now in this type of constraints, right? Like first of all, we will be covering about the entity related constraints, okay, which will be like a primary key and the unique key. Okay, now first of all, we will be using the learning DB to just select it. So let's just run that and select the learning DB, and then we will drop any of the existing tables which were there earlier. We do not want them because we are going to restructure them for this session. So let us just run them. Okay, now we are creating a table again as we created earlier in the previous session. We will be creating the course table. So let's just create the course table. Now let's just start about let's just understand about the entity. Now what is the entity type of constraints? So it contains two type of constraints. One of them is the primary key, second one is the unique key. Now what is primary key? Primary key is a it's a key which uniquely identifies each record of a table, and so that it can be called as a candidate key. Okay, because it is identifying uniquely each record, so there can be one key or there can be more than one key. Okay, now all of those keys, even if it is one or more, all of those keys will be also known as candidate key. And out of this many candidate keys, if you pick any single one from those candidate keys, then the one which you picked will be called as primary key, whereas the remaining ones will be called as alternate key to that. Okay, now the second point, it does not allow the null value in the column on which it is defined. Meaning, like let's say you created like a primary key column, right? So that primary key column cannot have any single null value within that. That's fairly simple. So now then the third point, a table can have only one primary key. It cannot have more than one primary key for a table. Okay, now if it is defined using one or more columns, okay, now if the primary key is defined using one column or say more than one column, in the case of more than one columns, it can be known as a composite key. Okay, in that case it can be known as composite key. Now when you define a composite key, we need to understand that it can allow the duplicate values within that column, but not the null value. It can allow the duplicates, but in a way where one of those columns, in combination of all those columns, the primary key must be unique in a way. Okay, even though if it is repeated column, repeated value out of say like a 2 to 3 columns you combined as a composite key to make it a primary key. Now out of these 3 columns you need to have one or two columns, one or two columns can have the repeated values, but still in at a whole, like all 3 of these columns should be unique for the entire table, right? For that is how you can define, or that is how you can update or insert the values within them. Now the fourth point is, it is used to enforce the uniqueness as well as referential integrity. Means enforcing the uniqueness means we just saw that, right? Uniqueness is applied because the primary key itself is restricting the user to allow only unique values. At the same time, it does not allow the null values, so it becomes unique in that sense. Then what in addition to that, it is also maintaining or providing the feature of referential integrity. How come? Because if you define a column for a table as a primary key, then it can be helpful to establish the relationship between the other tables. With this table you can establish the relationship of other tables, which say like if suppose say you consider say like a course table. Now course table, say like we defined a primary key onto it, means this will become the primary table or say like a parent table to that. Okay, this will become the parent table, whereas the child table will be the table which will be referring to this table, that we will cover up afterwards, like in the 4.2.2 where we will learn about the referential key, but just now I am just explaining like that. So for that say it is like a referential integrity concept also, it is helping us in that case. Okay, now the fifth point, when you create a primary key with that constraint itself, it is creating an index on those columns. Okay, now what all columns that you covered, on those columns it will create a clustered index. So now let's just see in an action. We just created two columns for a course table called course ID and course name. Now currently let us just go and see the structure of the table under the learning DB, right? So under learning DB we see the tables, and the tables has stage.course as one table. Now in this table there are two columns. Do we see any constraint for that? No. Do we see any index for that? No. Right? So there are no constraints, no indexes, right? No indexes, no constraint, and keys, no keys are there. Now what will happen? It will have one key. After we apply this primary key, it will have one key. It will have the index, which is like a clustered index, which will be created after we create that. And that is what I am saying in this last step or fifth point, that clustered index will be created after we add the primary key to the table. So let us just run and see and verify how it creates that. Okay, let's just it executed successfully. Now just refresh the table and see. Okay, now what we see, primary key, the key is present. Now key constraints, it won't be there, only the indexes will be created on top of it. So two things it creates together. One thing, it is creating the primary key, and it is adding a clustered index, okay, on top of this primary key column, which is course ID in our case. Okay, now let us just define a table. See, now as we just saw that how we can define the how we can add the constraints. See, like we created the table, we forgot to include the primary key in that table in the design time. Now if you wanted to add that, how can you add it? That is what we have just seen. Okay, so if the table was created and you needed to add the primary key constraint after the creation of the table, then you will create it this way: alter table, table name, add then the particular column, but add constraint, constraint name, and then constraint type, and then the column name. Okay, that is how the constraint can be added to it. So this is the way after the table is created. But say like while creating the design of the table itself, you are very certain that this is the column to which you want to make a primary key, or say like any other constraint. So in that case, how you can apply is, while design time only, you can just declare all these columns, and then after them in the last give the comma, and then say constraint name, which is primary key underscore student is the table name, and then the constraint type is primary key, constraint type is primary key, and the column name is student ID, which is this. Okay, so for this table we want to make this student ID as a primary key, and in the backend the system should refer this column, or system can identify this column using this name, which is the alias name, or say like a constraint name called pk underscore student. Okay, so let's just run. All right, so now again just refresh it, refresh the tables, and then you can see the student table as well. Now within the student table, student ID is primary key, so key should have that primary key listed, right? That is there. The name which we have given, the same name, you can find it here. The same way you can check the constraints, the indexes. So with the same name, the index should also be created, and the index name should be clustered index, because the primary key is created, so clustered index should be created on top of it. So yeah, both of these things are there. Now let us understand the unique key. Now how unique keys are different than the primary key. See, primary key, we have seen that it can have only one column. Primary key can be created for a table, but it can be defined for it can be only one for a table. Okay, whereas in the case of unique key, a unique key also ensures the uniqueness. It creates the non-clustered index on a column, and for a table it can have more than one column defined as a unique key. So that's the main difference in there. Primary key can be defined for us, only one primary key can be defined, whereas unique key can be more than one for a table. Okay, then the second one is unique key still allows one value, one null value for a table, whereas primary key doesn't allow it. Okay, the third point is primary key creates the clustered index on the table, whereas unique key creates the non-clustered index. The difference between these two indexes we will learn in the subsequent module, but just for now understand that there is a difference of the type of index which gets created on the column or on the type of constraint. So unique key constraint creates the non-clustered index on a table, whereas the primary key creates the clustered index. And the key also ensures uniqueness, because it allows the uniqueness, but it does allow the null value just once, whereas primary key doesn't allow any single value even. Okay, so just remember that. Now let's just run this syntax. Just understand the syntax. What is the syntax? Alter table name means like the stage.course table, and then add constraint name, and then the constraint type called is unique. For unique constraint, the keyword is unique. For primary key constraint, it is primary key keyword, and constraint, then constraint name, and then constraint type. So here the constraint type is what? Unique. So add constraint name, constraint type, and then the column name. So let's just run and see. Okay, so this is also added. So now we should be seeing two things. First of all, the column needs to have the unique key applied to it, and the unique the non-clustered index should be created after adding this constraint, the unique constraint, right? So let's just refresh this table, the student table, and see that. Okay, so indexes we see that clustered index, we have created it on course table, right? So let's just refresh the course table and see like what is the index for that, right? So yeah, so in this table we created the clustered index on non-clustered index on, or say unique constraint on course name column. So this is like a constraint, unique constraint, but it is of non-clustered type, right? The previous one which we created was clustered index, whereas this one is non-clustered, and it is created on which column? The course name column. Okay, here it won't show any indicator, but in the primary key only it will show that key symbol. Okay, so you can understand, yeah, it's a primary key. All right, so now we can move on to the subsequent part, which is to understand is the referential constraint. We understood the entity constraint. Entity constraint had primary key and the unique key. Now we will learn about the referential key, which will be foreign key. Now what is foreign key? By term itself we understand that foreign means outside the country, means outside the premises, outside the region, right? Like that. So just understand in the same terminology you understand that outside of the it is referred outside of the current object, right, in that case. So in as per the definition, if you want to understand how it can be understood is, referential integrity constraint is a relationship between the parent table and the child table. Means this referential integrity constraint is a relationship between the parent table. Parent table is what? Parent table, say like in our case, like the parent table is a course, because course table has a course ID as a primary key, right? But in our student table, we want to refer to the same course ID column because we have the course ID present in our student table as well. And here, because each student will be mapped to the particular course, for that reason we want to establish a relation with the course table. Now how can we establish this relation? Using this course ID of the student table. And it will refer to which column of the course table? It will refer to the course ID column of the stage.course table, right? Which is the parent table in our case, because here in this table we do not have the values which are, we have the values, but it is making sure that the value which is entered into the student table aligns with, or say matches with, the table in the parent, matches with the value in the parent table, which is the stage.course. So in that case, so how can we identify these two tables as? Like, so in our case, stage.course is our parent table and the child table is our student table, right? So parent table's primary key, which is course ID, will be matched with child table's foreign key, which is this, right? So both of this value should be matching, should be identical in our case, because if it doesn't match, it will throw an exception called referential integrity constraint violated, like that. Okay, so it will throw up an exception. System automatically will throw an exception saying like it doesn't align with the value which should be present in the parent. Suppose, say if there is a course ID number 1, and here in the stage.student you are assigning a course ID as 2. Now if 2 as a course ID is not at all present in the stage.course, then what will happen is the system will throw an integrity constraint violation error, like this cannot be inserted into the student table. Why? Because that 2 as a course ID, what you are trying to add here, it is not present in the table called stage.course, right? So that kind of binding is established using this referential integrity constraint. Okay, clear? So let's just understand by definition again. Referential integrity constraint is a relationship between the parent table, which is with primary key, and the child table as foreign key, where child table requires that all foreign key column values must match to the parent table primary key column values. So in our examples, like the parent table, which is stage.course with primary key called course ID, which will match with child table stage.student with foreign key of course ID, right? That is how it will match the content of the column and establish the relationship. Okay, now let us just understand some of the rules before we actually implement the constraint on it. Okay, so there are some rules in let me just explain you by this syntax first. Okay, now by default, when you try to add this constraint called foreign key constraint, right, or referential integrity constraint. So the syntax is very fairly similar to how we created up to here. Okay, so how it will be: alter table, table name like stage dot student. We are applying the foreign key constraint, add constraint, constraint name, constraint type is foreign key, and then the column name. Column name belongs to the foreign key table, which is the child table of student. It refers to what? It refers to the stage table, the parent table, the stage dot course, and refers to which column? The course ID. So that we are writing here as reference is stage dot course, and in the parenthesis we'll put in the column which is map, or which is what we are trying to match it with this foreign key column, right? So the syntax is easy now. After we add up to this, there is a syntax to apply the constraint specifically while you apply the DML operation onto this particular table. Let's say you applied the constraints. Okay, so by default what will happen is, when you establish these constraints, what will happen is, if you try to add a record to the course table, it will allow, because there is no binding, because itself is a primary key. It won't throw any error. But while you try to add the record to the student table, it will keep on adding the records, but it will make sure all of the course IDs that you insert as a record into the student table, it should be present in the course ID column of the course table. If it won't, then it will throw out an error. Now say we created both these constraints, but say like there is a rule that we want to apply. What kind of rule? Means like if there are any deletion happens on say like the parent table, means suppose say now there is a need that arise that after some point we have like deprecated our one of the courses. Let's say we had 5 courses earlier. Now out of 5 courses, there are 1 or 2 courses that are no longer we are offering. Okay, that those are like no longer explained by our institution, suppose. So in that case, what we want to do, we want to remove them from the system, right? Now the history is mapped to those 2 courses as well, because the previous students, like in our past batch students, will also be referring to those particular courses, correct? So the references will be linked, means those students record will still be referring to the must be still referring to the courses that we are planning to remove. Now what should happen with those record is what we are making sure by applying these rules. What these rules are: by default, when you delete such kind of record, when you want to delete a record from the parent table directly, because if you directly remove that course, what may happen is the child table record may become stale, because it will say that the student is referring to say like course ID 5, but course ID 5 that you have already removed from the parent table. How it will work? It will become stale record, right? So to avoid that mismatch within the relationship of the tables, the by default system applies the constraint as no action. First of all, the default thing is no action. When there is a relationship between parent and child, if the table won't allow any update or delete, if it is set, means when you set this option, right, no action, it means what? It will not allow you to update or delete the parent record from the parent table. Okay, if this constraint is set by default, because and the parent table's reference records are thrown, it will throw an reference key constraint violation error like that if you apply this no action in that case, right? So this is the optional, but by default this is the applicable constraint on that. Then the second kind of constraint, which is cascade. Cascade, how it is applied? just change the keyword in this on delete operation from the master record, meaning like the parent record. If you are deleting that record, it will apply this cascade, means if you delete the record from the parent table, it will delete the record from the child table itself. That is how this option will work, cascade. Okay, and if you update the parent record, it will update the child record as well. That is why these two options, that is how these two options are working. Then the third option is like null. How it will work is, it will make the null value. If you delete the parent record, then how it will react on the child record is, it will set the null value, because the parent record is missing now, right? Now that reference, say like course ID 5, if you remove that from the course table, then the child record from the student table will refer to 5, but it will have no value. So it will do what? It will set it to null instead of 5, just because of those deleted record, right? Then the update also works the same way. If you have updated, say like a particular record in the parent, then it will accordingly, it will go to the child record and make that value as null for that particular column, right? That is how this constraint works. Then the default constraints. Now instead of setting the null value, if you remove the parent record, there is some value that you want to update in the child table, right, for that particular record of the column, right? How can you update? Instead of that, you may put some value instead of like this set default, means you may put in the brackets, say like here you may put in like 0, suppose. For example, I'm just saying, suppose you have removed the record from the parent. In case of this delete, right, which value you want to set, what value you want to set in the child record is 0 instead of null. That is how it will be. Then in case of update, the same way, if there is an update into the parent table, the child table update will do what? Go to that particular record and updates that value with the value as 0 in that referenced column. Okay, so that is how this constraint works. So by default, I mean it considers the no action, the first option that we explained, which will just throw an exception. It will not allow the user to take any action. It may not allow user to remove the parent table record, any of the record, because this option is by default enabled. Okay, so just make sure, if you are setting the foreign key constraint, if you want such kind of if you don't have any specification, then just go by with the default option. But if you have the need that you want the child table also to be removed or affected, then go by the respective options out of these 4. So in our case, we are applying this on delete cascade, means if you delete a record from parent, it will delete the record from the child as well. Okay, so there won't be any missing references record. Okay, so let's just run this constraint, and this is also created on the student table, because we are creating a constraint on student, right? So the keys will be foreign key in this case. Okay, so key will be created which is called foreign key. So whenever you say like primary key is created, then this symbol will be there for that. Whenever there is a foreign key, then foreign key will be reverse icon to that, like that. Okay, so just this simple difference between these icons, so you can understand like how it is different in that case. Okay, now the third type of constraint, which is the domain constraint. Now domain constraint has not null, default, and the check constraint. Now first of all, not null constraint. What is not null? Not null will enforce the users to input a value against the column while creating or updating a record. Meaning, say like when user is creating a column, say like you are altering a column called gender, right? by the character 1. Earlier maybe it was 2 or something else, or maybe it was not present at all. We are altering that column itself now, suppose. Okay, now student table is gender character 1, and what is the type of the column, which is not which is nullable here, right, currently. So what we are trying to alter here is we are trying to alter the column and make it not null constraint, so that whenever user will create a record in the student table, it will never allow the gender column value to be null, meaning it will force the user to input some value for this column. Okay, that is how this constraint work. So alter table, table name, alter column, column name, then the type, and then the constraint. This syntax will be little different because it is not treated as a constraint here. It is treated as if like a normal column definition. Okay, but in the other cases that you see, that this is how it is implemented. Okay, so let us just run this. So just create this not null to the column and it applies onto that. Okay, yeah, so gender is become not null now. Okay, now default constraint. Default constraint is what? When user doesn't input any value against the column, then the default value is inserted for a new record. Let's say you have a column called is active. Now currently, say in the course table, okay, let's just go to course table and see how many columns are there. We do not have the column called is active, okay, currently, or say we have it, in fact. Okay, right now suppose say we have it. Now what we want to do is we want to apply the default constraint for that is active column. Maybe that the column is there, but it doesn't have the default constraint applied on it. So what it will do is, by default the column is of what kind? It is of nullable type, right? So what will happen is, when somebody will try to insert a record to this table, it will allow the user to insert a null value, or say like it will allow the user to keep the value as null for this column, which is active column. So to avoid that, what we can do is, by default whenever user just creates this record, and instead we want to user to force that some value, instead like we want to force the user, by default we want to force that by design time only we want to force that user, by design it will insert the record as 1. Okay, so now let us just run this. Okay, alter table, table name, add constraint, constraint name, default constraint, and then the constraint, what will be the value that you want in the is active column, that is what we will be passing in. So whenever there will be new record user will be inserting, by default, even though user will not pass, system will pass 1 as a value for that is active column. That is what will happen. Okay, so that is the purpose of default constraint. Okay, now let us understand about the check constraint. What is check constraint? Check constraint enforces the users to input the value in the defined criteria, or say in a condition, criteria or condition against the column while creating or updating a record. So what happens here means, like you are adding a constraint here. Say like you are, let me just run this constraint first and then I'll explain. So here which call a table, like student table, right? So now let's just go to the student table and refresh the columns of the student table. We see that date of birth is the column here of not null constraint is already there on that. But what we want to do is we want to force the users, right? We want to force the user to put in the date of birth, means we want the users to be enrolled for our course if the user is of 18 years of age. Okay, if there is a criteria for our course enrollment, right? Say like 18 years of age only, the minimum 18 years of age person can only enroll for this course. So in that case, how can we make sure that the student who is enrolling, his date of birth is, or his date of birth should be in the range of, or should be in the range between 1986 0101, means the first month and the first of the particular year, right? So the 1st January 1986, that is the between. So the start range will be this date and the end date range will be 2007 December 31st. So between this two date range, the date of birth should be entered by the user for the particular student, right? So if the date range goes out of this range, it will throw an exception saying that constraint, check constraint is violated, date of birth is not acceptable, right? So it will force the user to provide a specific type of value, a specific range of value within this column. That is why this that is how these check constraints work. Okay, so that's it for this module. Happy learning. Thank you.